All right, so I'm going to go through this video pretty quickly. I had the answer key out there already. The answer key goes over all the definitions and things like that. I'm just going to go through some of the calculations here. If you have any questions, please reach out. So when it says how many pieces of data were less than 28.5, and since 28.5 is the upper boundary, we know that to find our upper boundary, we take our upper class limit and we add that 0.5 to it to get that 28.5. So that means our highest value that we can have in this point is 28, which then means every single value in this class boundary has to be lower than 28.5 since our class limit is highest class limit is 28. So then we will add these three together. So 12 plus 9 plus 4 is equal to 25. So that means 25 pieces of data were less than 28.5. For this one, it talks about how many students do their homework daily. Well, there's 4 students that do their homework daily, and there's 18 total students. And 4 divided by 18 is 0.222 repeating. So if you times that by 100, that will then give me 22.2% of students complete their homework daily. For this next one, I'm not going to do standard deviation now because there's another problem. I'm going to do it later on. If you need to know if you got it right or wrong, the answer key is out online. So for our mean, or actually before we even get started, since I know we're going to be finding our median and mid-range, we do need to put these in correct order. So I'm going to do that first. So we will have 12 and 12. Then we will have 3 15s. So we have 15, 15, and 15. We have 2 18s. So we have 18 and 18. Then I have 22 and 30. So since I need to for my median and mid-range, I'm just going to go ahead and put them in order now. Then I'm going to go ahead and add these together. So 12 plus 12 plus 3 15s plus 2 18s plus 22 plus 30 is going to be 157. So finding our mean, we first need to add them up. So it's 157. Then we divide by the number of pieces we have, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. And when we divide by 9, we will then get 17.4 for our mean. For our median, or for our mode, we'll do next. Our mode is which one occurs the most. So 15 occurs 3 times, 18 and 12 twice. Well, 3 is more than 2, so that means 15 is our mode because it occurs the most. Our median, after we go ahead and put these in the correct order, we need to figure out, well, we have 9 of them. So since we have an odd number, we do 9 divided by 2, which is 4.5. So that means we need to have 4 on each side. So 1, 2, 3, 4, 1, 2, 3, 4. So that means 15 will be our median. And then our last one, our mid-range. For this one, we take our smallest number, which is 12, and our largest number, which is 30. We add them together and divide by 2. So 42 divided by 2 is going to be 21. So our mid-range is 21. All right, what is the range of numbers? So the mid-range, we added them together and divide by 2. Well, the range is we take the highest value, which is 11, and then we subtract the smallest value, which is negative 8. And when we subtract negative 8, that turns to plus, so that means our range is 19. So that tells us how many numbers are, how many numbers our data set covers. So we go from negative 8 to 11, so that means there's a total of 19 numbers in between from our smallest to our largest number. All right, so for this one, it says student scored 74 points on the test where the mean was 80 and the standard deviation was 5. Find the student's z-score. You do get this formula on your final. So it's x, which is your score, or the score that you're looking at, minus m, which is the mean, over top of our standard deviation. So in this problem, it will be 74 minus 80 divided by our standard deviation, which was 5. So it's negative 6 over 5, which is equal to negative 1.2. So their z-score was negative 1.2, or choice D. All right, this is one of the ones I told you that you should use if you have 2 different colors, just because it makes it a little bit easier for you. But it says, if an apartment is selected at random, what is the probability that it is on the 3rd floor or has 1 bedroom? So first, I'm going to highlight the 3rd floor. So if I'm choosing the apartment, well, first, before we do that, actually, let's figure out how many total apartments we have. So this one, we have 6. 3 plus 2 plus 1 is 6. This one, 2 plus 4 is 6. And then we have 4, 3 bedrooms. So that means we have a total of 16 bedrooms total. Or 16 apartments. That's how many apartments we have in this complex. So then our 3rd floor, we have a total of 6 3rd floor apartments. So we can then do 6 over 16. And then we will find how many one-bedroom apartments we have, which are these three here. So we have a total of 6 one-bedroom apartments. However, if you notice, we had one apartment that was both on the 3rd floor and one bedroom. So we need to subtract that apartment out because that means we accounted for it twice. We accounted for it in our 3-bedroom or in our 3rd floor, and we accounted for it in our 1-bedroom. So since we counted it twice and it's only one apartment, we need to subtract it out. So 6 plus 6 is 12, minus 1 is 11, so that means 11 over 16. So if we are choosing an apartment at random, we have the probability of 11 out of 16 to pick an apartment that is either on the 3rd floor or has 1 bedroom. All right, the next one, find which number corresponds to the 65th percentile. So when we're doing this, we're finding percentile. We also need to put them in correct order from least to greatest. So 10, then it will be 14, 15, 18, 23, 44, 56, 72. Right now, this formula you will also get. So n, which is the number of data that we have, times p, which is a percentile that we want, divided by 100. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8. We want a 65th percentile divided by 100. Well, 8 times 65, so this will then be 480 plus 40, so 520. Divided by 100, which is equal to 5.2. Since this was a decimal, you always round up. And it rounds up to 6. So that tells us what number we need to go to. So 1, 2, 3, 4, 5, 6. So that means our 65th percentile is the number 44. So our answer for this is 44. Now, had it asked for our 60th percentile or 50th percentile, we would do 8 times 50 divided by 100. Well, 8 times 50 is 400. Divided by 100 is 4. Remember, if this is a whole number, we can't round up, but what we do is we go to that number, which is 1, 2, 3, 4. We take the 4th number and the number after it and find the average. So it will be 18 plus 23 divided by 2, which is equal to 41 divided by 2, which is 20.5. So that would be your 50th percentile. So I know it doesn't ask you for this in this question, but just in case it's on the semester exam, I want to show that again. But remember, if it gives you a decimal, you always round up, no matter what it is when you're finding your percentile. All right, this one I just want to just go through again. Something we talked about earlier in the year. If so this will be our lowest value. This will be our Q1, our Q2, which is also our median, our Q3, and our highest value. So if our Q2 is closer to the right, that means that we are skewed left. If it is closer to the left, that means it is skew right. If it's right in the middle, which is what it is now, then that means it is a approximately or a normal distribution. Or you can say it is symmetric. All right, this one we're finding standard deviation. I do give you the formula on your test, but I'm just going to go through it the longer way right now. You can use your calculator if you want to as well. This will be the population, as it says here. All right, so if you want to, the first thing you do is you would find the average. So 5 plus 20 plus 12 plus 3. This will give me 25, 37, 40. We have 4 numbers, so the average is equal to 10. Then you create a table. So you write your numbers down. It doesn't necessarily need to be in order. I'm just going to write them in order now anyway, but 3, 5, 12, and 20. All right, then you do your x, or your value, minus your mean. So 3 minus 10 is going to be negative 7. 5 minus 10 is negative 5. 12 minus 10 is 2. And 20 minus 10 is 10. And then your next step that you do is you take that x minus your mean and you square it. So negative 7 squared is 49. This will give me 25, 4, and 100. Then you will add all of these up. This will then give me 65, 74, 78, 178. So it gives me 178. Then after you take that number 178 and you divide it by the number of data that you have, which is 4. And 178 divided by 4 is 44.5. And then you go ahead and take the square root. And when you take the square root of 44.5, just give me 1 second. The square root of 44.5 is equal to 6.7. So that means the standard deviation for this population is 6.7. All right, so you take your mean, you subtract your mean from each of your data set, and you square it, you add them up, divide by the total number of data you have, and take the square root. The formula I'm giving you on your formula sheet is going to be this formula here. So the square root of the sum of your x minus your mean squared divided by n, your number of data. All right. Now for this one, you will not be getting the deck of cards, but you will be getting some information about the deck of cards. Like I tell you, there's 4 suits. I tell you what suits there are. I tell you what colors there are and things like that. But you will still need to be able to know how many are in each one. So if you draw a deck of cards from playing cards, what is the probability that you would draw 5, 6, or spade? So we know that we have 52 cards, and we have 4 5s, we have 4 6s, and we have a 5 of 6 and a 5 of spades and a 6 of spades. So we need to subtract 2 of them out because those 2 are already accounted for in the 5s and the 6s. So then this will give us a total of 6 out of 52. If we reduce this, it will then give me 3 out of 26. So we have the probability of 3 out of 26 of finding a 5, 6, or spade. The next one, I'm sorry. I'm doing these really fast. I'm not really even thinking. I'm sorry. The number of spades that we have is 13, and we have subtracting sorry, I did this a little bit quick, so let me just go back. So we have 4 5s, 4 6, and spades. We have 13 of them, but out of those spades, we have a 5 of spade and a 6 of spade. So we need to subtract the 2 cards that are duplicate out of these. So when we subtract those, we would get 4 plus 4 is 8, plus 13 is 21, minus 2 is 19. So we have the probability of 19 out of 52 of picking a 5, a 6, or a spade. All right, the next one, a 4 or a red card. Well, we have 4 4s and 26 red cards. But of those 26 red cards, 2 of them are 4s, so they've already accounted for, so we need to subtract those. So then we have a total of 28 out of 52, which if we reduce this, 4 goes in 28 7 times, and in the 52, 13. So we have 7 out of 13 of picking a 4 or a red card. All right, this one's really easy. If 70% of people surveyed said that they're going to watch the World Cup, what is the probability of selecting someone that will not be watching the World Cup? Well, we know that all of our probability adds up to 100%. Or 1, so we would subtract the probability of the event happening, which is 0.7, and that will give us 0.3. So that means 30% of the people will not be watching the World Cup. All right, I changed this one. On your review, it says 4 times. Just do 3 times. That's what you're going to be seeing on your exam. But when you do this, you need to figure out what are all the possibilities. So you can flip a heads. So let me write this out a little bit different. All right, so when you're flipping, you have your first flip every single time, then you have your second flip, and then you have your third flip. So if you flip a coin, your first time you could get a head, your second time you could get a head, and the third time you could get another head. You could do the same this is actually not needed, so I'm just going to go ahead and delete this. You can go ahead and do this again, and you keep doing this experiment where you're just flipping a coin 3 times and seeing what you get. You can get a heads your first time, a heads your second time, and then the third time you get a tails. You can get a heads, a tails, and a heads. Now, even though these both only have 1 tails in it, they're different events because in this one, the tails took place in your third flip, while this one, it took place in your second. So you need to go ahead and fill out all the possibilities. So what I like to do is I like to start with all heads, and then to see how my tails is trailing along, so it's 3rd to 1. And then I'm going to move back and do tails for 2 of them, because I did all the ones where we can have 2 heads and 1 tails, and now it could be heads, tails, tails. It can also be tails, tails, heads, and then it could be tails, because now it's all the possibilities for 2 tails. Now this heads is going to move along, so tails, heads, tails. And then heads, tails. We already did that one. So we actually, the only one that we have left is tails, tails, tails. And I know I have 1, 2, 3, 4, 5, 6, 7, 8. And to figure out how many options we have, if we do 2 to the third power, that tells us how many possibilities we can have. So now we want to get at least 1 heads. Well, the only one that does not have 1 heads is this that has all tails. So there's 7 possibilities of having at least 1 heads. And there's 8 total outcomes. So that means 7 out of 8 of getting at least 1 heads. All right. For this one, what you need to do first is we need to create a chart, and we're going to do class limits, class boundaries, midpoint, but you don't have to do this depending on what graph you want to do. What's the next one? Frequency and cumulative frequency, which you also do not have to do depending on what graph you want to do. But remember, the first thing we had to do is find what our class range and what our class size is going to be. So we need to find our highest value. Our highest value right now is 211, 218, 243, 320. So our highest value is 320. Then we need to subtract our lowest value, 170. 170. Let me just make sure it's 170. All right, 170. And then we're going to divide by however many classes we want. Now, there were some rules that we needed to follow when we're doing our test the first time, but I'm just going to do divided by 5 right now to see what this equals to, and I'll talk about the rules. So 320 minus 170 divided by 5, that is equal to 30. Now, when you're doing this, you really want to have an odd number, but we're just going to leave it at this for right now. Remember, 5 is the smallest class size that we can have. I'm just going to leave it here. It doesn't have to be odd. It's just, if you're not going to have an odd number, then I would highly recommend that you do not do the frequency polygon, because when we do our frequency polygon, we need to find a midpoint. So if you have an even number, just don't do that one. So I'm just going to go ahead and create this table. All right. And remember, we start with our smallest number. So it's 170. We do a different color, blue. And we add our class size to it. So that would be to 200. Then you have to subtract 1 from it because we're including that 170. So this will be the numbers that we'll put in our first class size. Then it will be 200 to 229, 230 to 259, 260 to 289, and 290 to 320. All right. Make sure that you're subtracting that 1 because this 170 is included. So if you were to go to 200, you'd actually have a class size of 31 in this and not 30. All right. Our class boundaries, we would subtract 0.5, so it would be 169.5, and then we add 0.5, so 199.5. We subtract 0.5, so 199.5. And then we add 0.5, so 229.5. I'm going to fill in the rest of the table. All right. I'm not going to do the midpoint part of this because since I had an even value, I know I'm not doing my frequency polygon, so I'm just going to skip that. All right. Now I need to go ahead and do my frequency. So from 170 to 199, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16 numbers that fell between 170 and 199. And then between 200 and 229. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 that fell between 200 and 229. between 230 and 259. So 1, 2, 3, 4, 5. So I have 5 that fell in between there. Between 260 and 289, none. And between 290 and 320, I only have 1 at 320. All right, and then our cumulative frequency is where we add them up. So this is 16. 8 plus 16 is 24. 24 plus 5 is 29. Still 29, and this is 30. All right, so now let's go ahead and on your test, you just have to pick one of them. So I'm only going to, remember, I'm not doing frequency polygon in this one. I'm only going to do histogram and ogive. So our histogram and our ogive, we both use the same X and Y, or I'm sorry, we both use the same Y axis or X axis, which is going to be our class boundaries. So it will be this here is what we will use. So it'll be 169.5 to 199.5 to 229.5 to 259.5. I'm just going to fill the rest in. All right, and then for our y-axis, we have to do our frequency. Well, the highest frequency is 16. So I'm just going to go ahead and count by fours. So 4, 8, 12, 16. So that way I can get all my frequencies. So then remember, our histogram starts from our lowest class boundary and goes to our highest class boundary. Well, for the first one, we had a frequency of 16. So we will then start here. Or I'm sorry, I made a mistake on this one. I'm going to just go ahead and erase this real quick. What we actually need to do when we're doing our histogram is our first axis starts with our lowest class boundary. So it will start like this because we don't want any gaps. So our first one will actually start from it always touches our y-axis. So it'll go from here down here. So it always starts with our lowest class boundary starts here. So we had 16 from there. Our next one, remember I told you you should probably shade in every other one. Our next one, we have a frequency of 8. So we will go to 8 and it's here. The next one, we had a frequency of 5. So it's a little bit more than a 4. So we'll go there, color it in. Our next one, we didn't have a frequency. And then our last one, we had a frequency of 1. All right, so that would be our histogram. For our ogive, it's very similar in that we still use our class boundaries. This time, though, we don't have to have our lowest class boundary touch here. As a matter of fact, we probably shouldn't. But now our y-axis is our cumulative frequency. So we need to go up to 30. So I'm going to count this a little bit smaller. I'll probably still count in fours: 4, 8, 12, 16, 20, 24, 28, and 32. Just because I figured it was a good number to work with. And now we just need to go ahead and our first beginning of our class boundary, it's at 0. And then we plot our cumulative frequency every single time. So it'll be 16, then 24. So at the end of our first class boundary, we were at 16. At the end of our second class boundary, we were at 24. At the end of our third one, it was 29. So we're almost done at that point. So it'll be 29. And at the end of the next one, it's still 29. And then at the end of the next one, it was just 30. So we plot over our points, and then we draw a line connecting them. So we draw straight lines connecting these. And that will be our ogive. Now, you do have to analyze these on your exam. So just give some sort of, try to give some sort of description about it. So here we can say that most of the teams' value is around 169 to 199 million, or more than half the team's value is less than 230 million. We can say that the change from 169 to 230 million is quite rapid between the teams because there's a lot of teams that are cost that, but then there's not many teams that are more than that, so it starts to slow down. It's just this we can say it is skewed to the right. There's a bunch of things we can say, so I want you guys to try and analyze this as much as you can. That is it for this video. If you have any other questions, please feel free to reach out.